Hello, I'm Robert Johnson, the host of a Build It Better podcast powered by FRAMECAD, and this is part 2 of our conversation with Andreas on the modular building trend, and not so much trend, but the rise of modular building methodology in construction. Fascinating conversation with him last week. This week we're going to end it. We're going to bring it all together for you. This also happens to be airing during the World of Modular, which Andreas is attending. So stop by, see the FRAMECAD team, and let's finish this chat. So there's one clear thing that's really come out here. This isn't something that you just jump into and do. It clearly is a design-led process. I mean, you have got to, okay, great. It's whether you're having to design because of the size and the transport, because you have to keep it within certain constraints for transport, or because all of these things have to fit together as pieces, and where's all the plumbing chases and where's the electrical going to go? It truly is a design-led process. Am I right?
Yeah, definitely. If I go back to my own experience, for example, with Interpod, the production is fantastic at Interpod. It's more like a car manufacturing, to be honest. It's a production line.
That's how people should look at it. It's like just the way you see all these things in these plants with cars going through, that's the way a structure is being put together.
Yeah, so it moves every 42 minutes at Interpod, for example. So you got a production line, it moves every 42 minutes. It's a very rigid and good process. It's all trained. It's all operations are planned. Everything is good. So not want to down talk the production side of it, but what's happening in the office, is very, very important, because it's very easy to set the guys up to fail in production unless you have spent a lot of time. So you always get the question, can you do one for me? Can we order 4? And for bathrooms, no, we want to do 40. But we just need a few. Yeah, but guys, I spend 6-8 weeks preparing this. So it's not only about the design. We do all the programming of CNC machinery, because out there we don't want to build, we want to assemble. That's what we want to do. So sub-assemblies, we can talk a little bit later about that, Rob, but it's very process driven. And I don't remember who it was now, but there was someone in UK that I looked at who'd done some research on these. And let's say it takes you 100% time or cost to build on site. And of that 100%, you had 5% in design. If you then take that you did it modular, you may save a little bit, and you might take 85% of the cost and time to do it modular. But of those 85, 30 were on design and preparation of making it absolutely perfect before it hits production. So it is design-led process. I mean, this might be different from different company, but where I've been, we have really had a finished, well-designed product that before it hit the production line, it was everything was ready. CNC programs. We used to make a pilot of each project to make sure we didn't have any issues, but it's all ready before it hits production. So yes, design led is definitely.
Well, yeah, because it's not like, out here, in typical traditional construction, you've got a slab and you show up, your framing crew showing up or whoever, and there's just, there's stacks of lumber. You show up with saws and hammers and nail guns and whatever, and you're putting together. And when you're doing all this in the beginning, you've got to design it so that at each different station, those people are going to be doing the exact same process every time with everyone that comes by taking advantage of the fact that they're going to get better the more that they do them, and they're going to get quicker. They're going to become more efficient. Lack of the quality goes up instead of going down. There's just a lot of stuff that you have to plan that you wouldn't typically do so in traditional construction, and you see that in, I think, many times a better product, a better end product, but there's just massive efficiencies all the way through the system that, yeah, it's going to take you. And we tell people this even in the panelization of, prefab cold form steel panels. It's design led. You're doing a bunch of work up front, much more than you would typical with traditional framing. But you see that when it comes to installation, you see all of those efficiencies, you see all the speed. You're not having to do a lot of changes, in many cases, none. So, yeah, it's a huge deal. You mentioned talking about doing sub assemblies and things. So, touch on that a little bit. You're talking about, and what I would take it is, there's some assemblies that you can prepare and have positioned prior to it being installed in an assembly line or on the floor.
Yes. So we let's put it this way. If I easily fall back to bathroom pots because that's where I spend most of my time. But one big driver that you might not think of if you're not in the industry is curing time. So you are if you just think of the time you spend on doing the operation or to do the waterproofing or to tile or things, you might miss that you cannot move on to the next station in 42 minutes after you're done waterproofing, because you can't tile on top of waterproofing that is 42 minutes old. So therefore you have, for example, we had a baseline, there's roof lines, there's wall lines, and all those lines are preparing these elements so that they are ready when they arrive. So, of course, you have stations like wall tiling, for example. So we actually developed a method together with waterproofing consultants and so on to be able to fully make the bases ready and have an area where we were lapping over walls and floors waterproofing. But you get to a time where you actually need to put the bathrooms into a little loop where they're curing to keep that rate of 42 minutes move. To be honest, 42 minutes is a made-up number that I just did, but anywhere is dependent on different projects. But it is we call it the line speed. And we also, when we start a job, we do something called line balancing, making sure that this is the perfect balance for this job.
So to use your example, you may get it to a certain spot. You may do waterproofing. It may take a left at the next corner and make a little, like you said, make a little loop so that everything's still moving at the regular speed, and then comes back into the line at a certain point when it's had its time to cure.
Yeah, that's what's happening.
Is it? But right now, the big thing is and again, I'll go back to a big buzzword in the U.S. and in other places in the world: affordable housing.
Yep.
And affordable housing is a big deal, and it's got to be this. And everybody thinks, oh, affordable housing is cheap housing. Okay, so they're making houses cheap enough that I can get into them, or you can get into them. I wouldn't. Yeah, go touch on this.
I was just about to say, I think it is a buzzword a little bit, because first of all, cheap houses does not have to mean poor material or bad quality. It can actually be that you have designed things to become cheap and effective while you're still using good, proper material and your product is good. Also, modular does not mean cheap or affordable. I just saw a house here the other week that is 1.2 million
A
modular.
modular home.
It's huge. Yeah, it's huge. It has a lot of very nice finishes and so on. So I do think modular is probably one good way of getting affordable. But it's more, I think, that we need to think more about the design. I mean, if you actually wanted to build something cheap, let's take away all the cuts of plasterboard. We're cutting everything because the architect have done it this way. What about optimizing all the sides so there is no cuts? Of course, there will be a few, but there is a lot of work to do to make sure that
Yeah.
you can use proper material, but it's more the process and the design that is that helps you save money.
Yeah. Yeah. Thinking about better ways of doing it. It goes back to this whole design led thing. If you really put the time in thinking about what you're doing, and you bring up a great point that I don't think is mentioned enough. Plasterboard, gypboard, sheetrock, as we call it here, that just you go to any job site anywhere. I don't care what kind of it's. There's just a dumpster full of gypboard, and somebody's got to put those pieces in that dumpster in the first place. Somebody's got to cut all those pieces and then put them in a dumpster that then gets moved to another dumpster. That's just one example. I mean, just
It's a
thinking
good
through
one.
things. Mm.
It's a good one because if we go back to I go to the bathroom pods again. So I use the nesting software. And nesting is for those who doesn't know, it's a software who will optimize the usage of a board. So I can tell, and if it didn't work out well on one project, I could actually combine projects. So we didn't cut our own boards. We ordered them from another company because we didn't want to have these in house. So I made a wall board layout, and I now took all these parts, told how much I needed, what boards were available, and I let the computer tell me, this is how you should do it. That's converted into CNC file, and it's very easy to order from. So you can save a huge amount of material by not thinking you're better than the computer in this. So that's the kind of savings you can do
Yeah.
in a modular industry.
Yeah, it's not just it's not in going out there and finding cheaper labor to build the thing, or buying inferior products. It's not that at all, and that's what people think when they're say they're getting. And I think this is really a massive point, is that it can be affordable housing and still be a very high quality home, or structure, just simply because of the advanced design and thought that's been put into it.
Yes.
Okay. So what I mean, we've touched on some of them. So in the modular world, whether it be bathroom pods, kitchen pods, a full blown modular home, or a module of stacking multifamily, what are the benefits of light gauge steel and using panelized light gauge steel? We've talked about weight, but here's one I
Yeah.
want to throw at you. So we talk about weight, and everybody that I talk to about modular construction here says to me, well, I'd love to use light gauge steel, but I can't lift it. I can't pick it up with a crane like I can a timber one. Again, you know what I'm talking about. They can't pick it up from the top corners of the building because it's light gauge steel. It's going to rip it apart. It's going to tear it up. We talked about this in our call. There's other ways to lift one than just lifting something but I mean, that's not a light gauge steel scenario. That's just a design piece.
I actually don't really. I might not understand what they're saying. It Steel has a benefit that our fasteners are going perpendicular to the members, so it's more of a shear than pull out. So if you have nails, you can pull them out,
Excellent
I
point.
don't
Yep.
really know what they mean that timber would do, but what I can say is I've seen um, this is an interesting topic. When you're building, I think an advice to modular builders is to really analyze every every step in the life cycle of a module, because you're adding a lot of elements in there, probably because 5 minutes of its life cycle, which is the lift. So you're spending a lot of money on these. And of course, it needs to be sorted. You can't lift something that is not structurally sound for
Get it.
lift. So it needs to be sorted. But if you have an example that you, yes, say we do 100 modules of a house or apartment blocks or anything. And in every one of these units, you're putting in 10%, 50% extra steel so it can be lifted. And that's
For
you're
5 minutes of the whole process.
Of this life cycle.
Mm.
It is worth investigating what kind. Let's say I instead take out that, I make it weak. It's structurally sound, perfectly for in situ, where it's going to be for the rest of its life cycle. And then look at equipment that can help me out to lift these. So, and this downside with that, you may have to transport that back to the factory and so on. But to find a lifting equipment that can reduce a lot of material in your module can save you quite a lot of money. So you just think of, it can't span this long. What about if we have two beams underneath here that is easy to pull out? They are reused every time. Another way I see is people, we're going to lift from the top. Okay. And you put a lot of extra material in your walls, in your ceilings, because you're going to make a strong module to lift from the top. What if you build a stronger base and just they are sacrificial lifting straps, if you can't get them out after, that you actually can put in there for a couple of $100 that can lift quite heavy things. And on site, you just leave them on. You can lift from the top. So you actually don't lift through on the walls. You can have the machine punching the hole through the wall, so you can run this strap and you can lift from there. So there's a lot of methods to save. Don't put all the lifting equipment in your design, in your module, and you're going to do a lot of them, and you're going to pay this for every single module.
I mean, you said it brilliantly. Because out here, and again, it's people, and it's a lack of experience. I understand. It's a lack of really thinking it through. You know, everybody just says, "Okay, I'm going to do modular construction, and I can do this, and I can go out and build a base." Like I always build a base, I can throw some walls up. I can finish it. I can basically build that just like I would build it out on site, but I'm going to build it in my factory.
Yeah.
Okay, now what do I do? Now what do I do? Now how do I move it? And they get out and they tear the thing up because they haven't thought through. But instead, like you say, their fixes are, well, add some structural steel in the wall. Let's do this. And they're just simply not giving it the attention that it needs, like you mentioned so brilliantly. For 5 minutes in the life cycle, it's one very minute piece is the lifting and putting it in place. And you're going to just throw a hand grenade in there because, it's you're going to make it much more difficult than it is. These are all things that I think that are great points that people in modular construction have to figure out or think about. You don't really have this issue in panelization. You still have to have pick points. You still have to be able to swing a panel into place or pick it up with a reach fork or a crane or whatever. but it's not near as cumbersome, obviously, as picking up a whole module. Adding structural pieces and components. I mean, it's important to select the right parts, right?
Oh yeah, it is. Um, we we have other situations of this life cycle thing that I have, for example, an example where we as we all our modules were reviewed and approved by external engineers. So you can have a floor, for example, we had a base, I think it was 1.8 meter, which is just a bit over 5 feet. And they came back, and then I need to add a lot more steel. No, but it's going to be it's fully supported once it's on site. It sits on the concrete. Yeah, but we're worried about the lift and so on. And we said no, we it's so firm. We are not worried as a company. We will comply once it's on site because it's fully supported. But it's before we're there. So they challenged us, and we actually made a big concrete block in agreement with the engineer to test the deflection because it's a tile floor. We don't want it to crack.
Yeah.
And I don't remember the weight of this now, but it was pretty heavy. And we measured the deflection. And he called me and he said, I need to know that deflection so I can use that in my calculation. I said, I can't give you a number. There was like 1-2 millimeter, which is 25 of an inch. I said, it can't be. And I said, it is. So I think it's with modular, sometimes it's worth challenging your engineer a little bit. But you want to do a good product because it helps you. You don't want to have defects. And also for your clients, of course. But computers may not be able to always tell the truth when it comes to assemblies. If it was steel only, yes, but with fiber cement boards glued and screwed to these members. So I think it's advice there is to really test and push limits because still these deflection can only happen during the lift. And if there is no deflection in reality, and we are supported fully once it's on site, so actually we managed to get this engineer to realize that it's a lot stronger than we thought.
Yeah, just such good stuff. What is something that you want us to talk about that maybe we haven't addressed yet?
Maybe I think from a light gauge steel point of view, there are some. We touched a little bit on the benefits. I as I said before, I do like my timber. Yeah, and but in a manufacturing environment, I think if you, let's say you are a factory who is doing modular, and you, in particular, if you're doing this manually, FRAMECAD is quite cheap investment for being able to automate your production.
Man, that's so well said. Yeah.
If you compare that to, what I use it over 8 years, I think now. If you compare that to manual, it's a huge improvement in time. Once you have a timber automation set up, it will be at least the production will be as good. But to do so, it normally requires quite a lot of machinery. So you want one for trusses, one for walls, and so. But while FRAMECAD's equipment is all in one, together with software as well, which is very important part of these. Again, we touched on less waste. If you think of using light gauge steel equipment, no matter what brand, you put that coil in, and the waste you will get is when you replace that coil, you may get an odd length of
Yeah.
2 meters, 3 meters that doesn't fit out of 1,000 meter long coil.
Yeah, your service holes, if you're punching service holes in it, just the flange cut, little, but
Yes,
that's just
they
nothing.
are a waste, but they're not a waste on your linear meter. So it actually doesn't take away linear meter for you. It does add to your bucket of scrap, yes,
Yeah.
but not from a linear meter point of view. What more to talk about? This.
What about automation? Is automation a big piece? And to me, I would think light gauge steel would lend itself better to automation. Am I right there, or is it just maybe not so because timber's been around longer and maybe more automation has been developed for it? But what's your thoughts on automation and robotics?
Yeah, so I'm a big fan. That's my background. That's what I did. Built automation. So I think take baby steps. So seeing quite a lot of companies setting up, go all in on automation, and why that can be a problem is that automation is normally, it can be highly flexible, but then it has a lot higher price tag. So my recommendation is that you automate the thing. Semi-automation is a good way of starting things you know that you're going to do always, because either you think it or not, your product will develop as you go because you will learn.
Correct.
So to start automating before you actually have a mature product that you have tested can be a big issue. So yeah, it's like learn to crawl before you walk a little bit.
Yeah.
I think automation is a very important part of the modular industry, and it's going to make us a lot more competitive against site build. But I would do it as I would increase my level of automation over time when I know that my product is stable or mature.
There you go. Yeah,
Yeah,
make sure that you've got your product right and the steps right and the pieces right. It's easy to automate when you've got it dialed in and you're replacing a guy that's putting a screw in something. That's an easy automation because now you know that the process works right, and I'm just going to take that guy out of it and make it quicker and more accurate if I do it with robotics or whatever. Um, Man, I've thoroughly enjoyed this. I want to mention again that Andreas will be at the World of Modular in March with the FrameCAD team. Now, we at FrameCAD, one of the roles that Andreas is doing is we're making Andreas available for consultation. How do people reach out to you if they want to start that conversation and dig into a little bit more about what it would look like for us to provide some consultation for them with design manufacturing?
yeah. I think you could talk to any representative, and they will pass my details on. Any representative of FrameCAD.
Okay.
Yeah,
How do people get in touch with you if they want to talk to you or ask you a question?
call me, email me.
Okay. And
I
we,
do
we
this every day, but have in mind, I'm in Australia, so now it's I'm a day ahead of you, and I'm in the morning, and you're probably in the evening. So
yeah. So don't be calling him at the wrong time. So I'm setting you up and I've actually got a lot of friends that I'm going to have call you when it's about 2 a.m. there. Um, I'm not actually. Um, Man, thanks so much for coming on. We're going to have you do this again. I do want to mention again that will be a 2-part series, and we may add some things in to the second half of this. We'll just have to see what we come up with. So As I've always said, we've all built it the old way. Now let's go build it better.